Hi everyone and welcome to this, my video on gradient-intercept form. This is where stuff gets really interesting. My name's Darren from Maths Guru. Thank you very much for joining me. If you are new, you will never have heard this before. If you're old, well, I don't mean old as in old as me, that's not possible. But if you're a long-time subscriber, thank you very much. But if you are new, do me a favor. Can you subscribe to my YouTube channel? That one little click from you really does mean the world from me. When I check at the end of each day how many people have discovered my channel and that number gets to 3 additional subscribers, I am literally the happiest person on this planet. Sad, but very true. Who watches maths videos other than my mother and the dog? A whole new discussion. So if you can do that, that would be great. What I'm going to do is work through some more of the Year 9 course here in Australia, but relevant all over the world, and hopefully it will make sense. If it does and you're on YouTube, leave a comment below. Let me know how I'm doing. But otherwise, what are we going to do? We'll know what the gradient-intercept form of a straight line is, be able to find the gradient and intercept from an equation, be able to write equations and rearrange linear equations. That sounds like a lot of stuff to get through. Here we go. So in previous lessons, what did we look at? We have been powering through, and again, if you want to watch the videos and haven't already done so, they're on mathsguru.com. Find x and y intercepts of straight lines, right? So we've so far looked at finding x and y intercepts of straight lines. So this one here is my y-intercept. Now again, a lot of people write that as just 2. It isn't. It's a coordinate. Please write it as 0, 2. Here is my x-axis intercept. And again, people get very confused with these one. And I think that's probably one of the reasons people do so badly in this. It's just they don't know the difference between an x-axis and a y-axis. All right, so there's my x-axis. And there is my y-axis, and fingers crossed, all should be good. Use intercepts to draw straight lines. Oh, we've used intercepts to draw straight lines in a previous video. That was very useful. We've drawn horizontal lines, we've drawn vertical lines, and now we're finding the gradient of a range of straight lines. Right, let's try and link them all together, shall we? We found all the individual stuffs. Let's see what we've got. Now, I've got a great program online. You guys get it for free as well, called desmoss.com. I'll write it down there, desmoss.com. And then if you do /calculator, it will take you to the graphing stuff that you can show here. And what I've done is I've drawn 3 straight lines. Now those straight lines have an equation of y is equal to 2x plus 1, y equals 2x plus 3, and y equals 2x minus 2. So what I want you now to do is, what do you notice about the equations? More importantly, what do you notice is different about the equations? Well, they all start with y equals, yep. They've all got 2x in them. But weirdly, one's got a plus 1, one's got a plus 3, and one's got a negative 2. I wonder what that's got. Well, it would appear that all these lines, 1, 2, 3, seem to be parallel. And if you remember, the definition of a parallel line is that it will go on to infinity and beyond without ever meeting. All right, so parallel, they'll go on and on and never touch. Or they have the same gradient. Oh, that's nicer. Although I'm going to miss Buzz Lightyear. Saying that they have the same gradient is awesome. And the way we can tell that, let's just see, is they all have this number 2. More on that in a moment. But what on earth is this plus 1, plus 3, and negative 2? Well, let's have a look and see where this one crosses my y-axis. It seems to cross at the number 3. This one here seems to cross at the number 1. And this one here crosses at negative 2, 3, 1, negative 2. Ka-ching! And believe it or not, that's so exciting, yes? But maybe the most important part here at the moment is the fact that when the number in front of the x is the same, then they should all be parallel. Oh, useful to know. So, what we can see from there is that all of those equations had a particular format. They all seem to look the same.